everyone. It's about 8:30. Let's give your colleagues about 2 more minutes. I have about 7 or 8 students on the on MS Teams. خلينا نستنى بس شوي, okay? Okay, let's begin. It's about 8:32. Let me start sharing the lecture notes with you. Hold on a second. Okay. Everybody can see it? Hello? Okay. Right. Okay, last time we talked about the last lecture, we talked about joint probability, conditional probability, and we also talked about total probability on page 16 of the notes you have on e-learning. And today we're gonna use total probability, by the way. And also we had an example on conditional probability and other applications. So we're gonna continue today with chapter 1, and today hopefully we're gonna finish chapter 1. So next lecture we begin with chapter 2. I have some notes for you on e-learning. As usual, في عندنا voice recording explaining everything. So today, really, I'm gonna go through it quickly, just in case somebody has any questions. Based on the feedback I get, the notes handwritten notes دائما voice recording is good enough. بس إحنا دائما we have to share with you notes الموجودات على e-learning. And walk you through it quickly, just in case somebody has a question or clarification about some of the notes or some of the examples that we have. So today we're going to begin talking about Bayes' theorem, as you can see here. This one is similar to the total probability, if you will. Now, if we assume that we have a set of mutual exclusive and exhaustive events. Those sets is B1 through Bn, as shown in this figure right here. B1, B2, B3, B4, all the way to Bn. And obviously, we talked about what we mean by mutual exclusive, as shown in equation 1 right here, where the intersection between, let's say, B1 and B2 will have to be equal 0, B1, B3 equals 0, and so on and so forth. And also, as far as the exhaustive, the whole set of the events, B1 through Bn, when you combine them together, will have to be equal to S, the universal set, okay? So let's assume also that the event A occurs, okay, which is right here, and you can see that there's an intersection between B1 and A, B2 and A, and intersection between that set and the event A. Now, by definition here, we can say that the probability of Bn, equation 3 here, I'm talking about equation 3, the probability of Bn given A is equal to the probability of A given B. This is conditional probability. We did talk about it last section, or last lecture, if you will. The probability of A given Bn times the probability of Bn divided by the probability of A, the event A, okay? Now, this equation 3, this is one form of the Bayes' theorem, okay? And also it can be written this way, okay? It can be written by the probability of Bn given A times the probability of A is equal to the probability of A given Bn times the probability of Bn, okay? Just in case if you want to write this way, that's fine too. And of course, equation 4 and 5, they are just defining the conditional probability. Like, for example, the probability of Bn given A is equal to the probability of the intersection of Bn and A divided by the probability of A. So this is straightforward from the conditional probability. Of course, we assume that the probability of A is not equal to 0. Otherwise, it's not going to be valid. Similarly, for the probability of A given B of n. Okay. Another form of example is similar to equation 3. The only difference is replacing this Pn, the probability of A, the probability of A, event A, by the total probability of A. And this was calculated last time on page 16. Okay. And so we replace the probability of A here in equation 3 with the total probability of A, which is basically the summation of the probability of A given Bn times the probability of Bn, where n is small n, of course, here. Probability of receiving 1 and the transmitting symbol is B2, or let's say 0, is 0.1. Of course, this is the error, okay? And the probability of receiving A2 or 0, given that B2 was transmitted, is 0.9. That's basically what this system is talking about, okay? Now, what we need to find is the total probability for A1 and A2 for the two events on the receiving side. And also, we need to find the probability of correct system transmission and the probability of system error, okay? Of course, we did talk about this conditional probability. Now, if we want to talk about the total probability for the total probability for A1, for example, and the total probability was the equation for the total probability is right here, okay, which is the total for the probability of A given Bn times the probability of Bn, where n is from 1 to n, capital N. Now, capital N in this case, 2, because we only have 2 symbols. So you multiply the probability, in this case, the probability A1 times B1, the probability of A1 given B1 times the probability of B1. Then the other symbol is B2, the probability of A1 given B2 times the probability of B2. So all these numbers are available to us because the first one is 0.9 and the second one is, you can see it from the figure right here, 0.6. And then similarly, the other one is 0.1 and the probability of B2 is 0.4. So the total probability for B1, for A1, sorry, is equal 0.58. Okay. We can do the same thing for the probability of A2. Okay, the same exact thing. So we have two events for B1 and B2, and we need to do the total probability for A2. We just follow the same approach we just did for A1, and the result will be 0.42 or 42%, if you will. Anybody has any questions so far? Okay. All right. The next thing we want to talk about, we need to find the probability of correct system transmission. The probability of correct system transmission, which means that the probability of sending B1 or 1 and receiving 1, the probability of sending 1 and receiving 1, or the probability of sending 0 and receiving 0. That's what we are trying to find. So according to Bayes' rule, so the first one here, the probability of B1 given A1, the probability of sending 1, the probability of transmitting 1 and receiving 1, okay, it's equal to the probability of receiving 1, given that sending the 1 was sent, okay, and then times the probability of B1, okay, which is 0.6 in this case, divided by the probability of A1, which is the total probability of A, the one we just calculated on the top right here, okay. So we plug in the numbers. After we put all the numbers together, you will see that the probability of correct system transmission for 1, the symbol 1, is approximately 93.1% or 0.931. Okay. So we can follow the same approach to find the correct system transmission, the probability of correct system transmission for B2. So this one, the probability of B2 given A2. So you, again, we use Bayes' rule right here. And after you plug in the numbers, you see that it's approximately 85.7%. Now we want to do the same thing to find the probability of system error received or transmission. Of course, we have, which means that you send 1 and you receive 0, or you send 0 and you receive 1. This is what so we need to find this probability. So the probability, the top one, the correct system transmission right here, the probability B1 given A2, it means we received the wrong symbol. Okay, so again, you use Bayes' rule right here, and after you plug in the number, it's the probability in this case is about 14.3%. Okay, so there's over 14% system error. Okay, for the symbol 1, where you send 1 and you receive 0 in this case. Similarly, the probability of B2 given A1, which is the probability of sending 0 and receiving 1 in this case, okay, is about close to 7%, which is 6.9% exactly, or approximately, okay. So that's it. I mean, the example here, it's a good example. It's talking about, you know, we apply Bayes' rule, we apply the total probability, we apply the conditional probability, and we understand the correct system transmission versus the error. So it's a good example. So I explained it to you on e-learning, and this is the second time we explain it. So I hope you understand it. If you have any questions before we move on, please let me know. Okay, I take it this example is clear to everyone, at least on the meeting or in the lecture. Okay, let's go to page 21 of the notes, where we're going to talk about independent events. And this topic is really important because we're going to talk about it some more later on. Now, you know, we're going to begin talking about single random variables, and then we're going to talk about multiple random variables and other topics, and we're going to use independent events or independent probability a lot. Okay, so basically, if we have two events, A and B, and these events, each one of them has a non-zero probability, which means the probability of A is not equal to 0. Similarly, the probability of B is not equal to 0. So we can call the events A and B in this case statistically independent if the probability of occurrence of one event is not affected by the occurrence of the other event. Okay. Now, mathematically speaking, we can say the probability of A given B is equal to the probability of A, which means that the occurrence of event A is not depending on B. So that's why it's only the probability of A. So, you know, it means we can, you know, they are independent of each other. They are not depending on, they have no relation in this case, okay? They are independent of each other. And that's why the probability of A given B is equal to the probability of A itself. And then similarly, the probability of B given A is the probability of B, okay? Now, if you recall the conditional probability, the definition of conditional probability, which is the probability of A given B, for example, it's equal to the probability, the probability of the intersection of A and B. So the probability of the intersection of A and B divided by the probability of B. Now, if we take equation 7 and plug it into equation 9 right here, you will end up with equation 10, which is says like the probability of the intersection of A and B is equal to the probability of A times the probability of B. So for two events to be independent, they would have to satisfy equation 10. So let's say if we have events A and B, and you want to see if they are independent, what you have to do, first of all, you will calculate the probability of A by itself and the probability of B, multiply them by each other, and then you find the intersection between A and B and find the probability of that intersection. If they are equal, it means they are independent. If not, obviously they are not independent. Okay, that's simple. Okay, so you have to do two things. The probability of A1, the probability of each event separately, multiplying by each other, will have to be equal to the probability of the intersection of the two events in this case. Okay, so as an example here, we have S as an event or sample space in this case is equal, has 4 elements, 1, 2, 3, 4, and each element or each element has an equal probability of 1/4 or 25%. Okay, and also we have 3 different events. A is equal 1, 2, B is equal 1, 3, and C is equal 4. And obviously they all subsets of S, which means that each element has the probability of 1/4. Okay. Now we want to see the first question is if A and B are independent. Okay. So the first thing you will find the intersection of A and B. What's the intersection of A and B in this case? As you can see, is 1. So the probability of 1 is 1/4. Okay. Now, what's the probability of A by itself? The probability of A by itself, as you can see here, A has 2 elements, 1 and 2. And they are 1 and 2, so you'll see 1/4 times 1/4 will be half. Okay. Similarly, the probability of B is 1/2. So 1/2 times 1/2 times 1/2 is equal 1/4. So as you can see, this part and this part are equal. Then yes, A and B are independent. Now the next question is, are B and C are independent? Well, okay. So we will take the intersection of C and B. Obviously, there's no common elements between them. Okay. It means the probability of the intersection is 0. However, the probability of C is 1/4 and the probability of B is 1/2, which means when we're multiplying by each other is 1/8. Okay. Obviously, 1/8 is not equal to 0. In this case, we can say that B and C are not independent. Any questions here? Everything's fine? Good. All right. The next topic is we were talking about multiple events. So in there, we talked about 2 events, A and B. Now, if you have multiple events, let's say in this case we have A1, A2, A3. Similarly, they are said to be independent. So if each pair is independent, So A1, A2, A1, A3, and as shown here in equation 11, 12, 13, I think they are obvious. Okay. And in general, if we have more than 3 events, let's say if we have n events, you do the same thing. So the probability of the intersection of all of them, A1, A2, A3, A4, it's equal for them to be statistically independent. The probability of each event, the probability multiplying by each other will have to be equal to the probability of the intersection of all these events together, okay, which is equation 15. And that's basically equation chapter 1, the end of chapter 1. Any questions? Okay. Page 23, I have some suggested problems for you for chapter 1. There are just few problems. Obviously, the book, as I mentioned to you, you can find it on the net. So is the solution manual. But what I ask you to do is try to solve these problems. These problems, obviously, you can do more than these if you want. If you feel that you need more practice, you can do more than the ones I'm giving you here. These are just representation of the topics we talked about this chapter. So I suggest that you try them yourself, and you know, once you try them, you see the manual if you want. Okay, it's available. And but if you feel like, you know, one of them is not easy to understand, maybe you can take a peek at the problem or the solution. يعني just take a hint and try to do it yourself. لأنه if you take a look at the solution, then obviously the problem would be easy to solve. Okay. And that's all I have any question. Anybody has any questions about the notes?
دكتور لو سمحت.
كل شيء تمام؟ ما سمعت.
دكتور لو سمحت.
تفضلي، الصوت مش سامعك كويس. الو؟
نعم دكتور، هيك أحسن.
في سؤال؟
دكتور، بدي أسأل إنه كيف بدي أحسب التوتال أوتكمز بإيفنت معين؟
كيف بدك تحسبي total outcomes؟ يعني ما حكينا قبل شوية. let's say هاي في عندنا for example الإكزامبل اللي حكينا عنه قبل شوية. هلا مثلا في عندنا let's go to page 20 صح؟ هلا التوتال probability، انت بتحكي على التوتال probability ولا لا؟
لا بالتوتال اوتكمز بايفنت معين، يعني زي صفحه
هيك يعني هو ما بقدرش هيك السؤال، هو بده يكون واضح، مش فاهم شو.
زي صفحه 10.
بدنا نرجع على صفحه 10. اوكي خلينا نشوف. طيب انت ما كنتيش موجوده بالمحاضره هذيك؟
بلا كنت موجودة دكتور.
اوكي طيب هاي الصفحة 10 بداية almost بداية chapter 1 ولا لا؟
نعم دكتور. هسا بالإكزامبل أنت حاط إنه إحنا بنحط الرولز بالإيفنت، تمام؟
نعم.
إذا أجاني بالامتحان سؤال إيفنت معين وأنا طلعت الجواب، بس للتأكد إنه كيف بدي أطلع التوتال أوتكم من الإيفنت نفسه.
في إكزامبل عملناه وأنا مش داري يعني شو اللي بتقصديه هون. يعني فرضا إنه إحنا أعطينا هون إكزامبل. أوكي التوتال أوتكم بيعتمد، يعني مثلا إذا كان في عندك if the outcomes are independent of each other مثلا you add them together، صح ولا لا؟
بدي أعرف كيف التوتال أوتكمز، يعني عدد الإليمنتس اللي راح يطلعوا معي بالأوتكم.
عدد الإليمنتس اللي يطلعوا
بالأوتكم.
هو بيعتمد على الاكسبيرمنت. مثلا فرضا جدلا خلينا نقول let's go to this example on page 10 مثل ما حكيتي، صح ولا لا؟ هلا الاكزامبل هذا شو بحكي؟ we are rolling two dice، صح ولا لا؟ سمعتني؟
نعم.
اوكي هلا rolling two dice، هلا rolling one dice، rolling واحدة شو بيطلع لنا؟ بيطلع 1 2 3 all the way to 6. so في عندنا 6 outcomes. هذا اللي تحكي عنه؟
ايوه بالضبط. نفس الشيء بالنسبة للإيفنت.
هي الايفنت هي عبارة عن ست. الايفنت عبارة عن ست. اوكي احنا بقينا نحكي بالاول سيتس. مثلا خلينا نقول الايفنتس هون مثلا A، خلينا نطلع على الاكزامبل الافضل شيء on page 10. في عندنا A is equal the sum of two خلينا نقول the sum of two numbers is equal 4، صح ولا لا؟ اوكي شو الاوتكمز هون؟ الحالة هاي بكون 2 2 1 3 3 1. so these are events. هلا الايفنتس بيعتمد انت يعني you set the rules. هلا التوتال اوتكمز اللي هو عبارة عن S اللي هي اليونيفرسال سيت. بعرفش انت بتسألي عن اليونيفرسال سيت في الحالة هاي ولا بتسألي عن specific event؟
أنا بسأل عن specific event، يعني صح طلع معانا 3 outcomes.
اوكي
أنا بدي أتأكد إنه هم 3 مش 4، ففي رول معين إنه أحسب إنه عدد الelements اللي طلعت معي.
ما هو دقيقة، هلا خلينا نرجع للإكزامبل نفسه. الإكزامبل نفسه في عندنا 36 outcomes. كيف طلع 36 بالحالة هاي؟ طبعا احنا we roll the dice twice. هلا if we roll the dice the die once شو بيطلع عندنا؟ 6 outcomes. This is the maximum صح؟ نعم. هلا if we roll them twice بصير عندنا مثلا أول واحد 1 1 1 2 1 3 1 4 1 5 1 6 بعدين 2 1. هاي صار 36 صح ولا لا؟ هلا هاي التوتال اوتكمز. اوكي 36. هلا الايفنتس بيعتمد انت يعني هاو، يعني مثل ما تقولي بيعتمد انت شو what you're looking for. In this case مثلا the sum of two numbers 4. هلا بتطلع على الايفنتس وبتشوفي انه your rule انه يعني two elements will equal when you add them up equal to 4. In this case we have 3 elements. ليش؟ لأنه أنت بتحط الأوتكمز together. أوكي؟ ووجدت إنه ما في عندنا أكثر من 3 elements for this particular event. صح ولا لا؟
نعم.
فما بدريش إنه يعني هذا سؤالك ولا مثلا خلينا نشوف إذا في إشي ثاني.
نعم دكتور شكرا.
اوكي بدي اتاكد انه في ممكن شيء ثاني شرحناه ويعني ما كانش واضح. بس الايفنتس يعني مثل ما تقول the total outcomes هي عباره عن يعني this is the universe set all possible outcomes. هلا الايفنتس بيعتمد انت مثلا هون the second one مثلا حكينا the two numbers are identical يعني زي 1 1 1 2 1 1 2 2 3 3 4 4 5 5 6 6. هذا هن اللي مثلا الايدنتيكال those are applied to this rule. اوكي هلا مثلا حكينا عن مثلا حكينا عن السيت and خلينا نقول subsets. اوكي حكينا عن السيت and subset. السيت مثلا اذا كان في عندي 10 و you can find subsets from them مثلا 1 1 مثلا 1 2 3 or 1 1 1 2. وحكينا انه the number of subset is 2 to the power number of elements يعني 2 to the power خلينا نقول in this case 10. اوكي بس على الاقل I don't think انك تسال عن الموضوع هذا. بتوقع انه اللي بتحكي عنه السؤال هذا ما بديش اذا جاوبناه كيف صحيح ولا لا. واضح ولا في عندك اسئله ثانيه؟
نعم دكتور شكرا.
اوكي في حد ثاني عنده اسئله؟ اوكي خلينا هنا اوكي اذا ما في عندكم اي اسئله يعني في عندكم اسئله general questions regarding الماتيريال ولا شيء ثاني او يعني الكورس in general؟
دكتور احنا هيك خلصنا chapter 1 صح؟
نعم وان شاء الله يوم الثلاثاء يعني كنت بدي ابدا اليوم بس دائما لما انهي شابتر بحب اني ما ابداش بشيء ثاني. فان شاء الله يوم الثلاثاء نبدا بشابتر 2.
تمام. هسه دكتور بالنسبه انه حيكون الامتحان مد بالعاده شو راح يكون الشباتر اللي داخله معنا في الامتحان ولا مش مبين؟
والله بالنسبه للمد انا ما عمري اعطيت مد للماده هاي. دائما بكون عندنا 2 exams exam 1 exam 2 بس قبل المد في عندنا كويز. الكويز راح يكون ممكن شو الاسبوع هذا ممكن الاسبوع الجاي او اللي بعده بحكي لكم يعني قبله. هلا المد بكير
من كم راح تكون ان شاء الله؟
كيف؟
الكويزات من كم راح تكون؟
موجوده على السيلبس حطيتها على الاي-ليرنينج. في عندنا 2 quizzes. في عندنا كويز the first quiz before the mid 10 points والثاني عليه 10 points هاي 20 والميد راح يكون عليه 30 points
ان شاء الله دكتور يعطيك الف
ان شاء الله. اوكي السيلبس موجود على الاي-ليرنينج اذا if you didn't have a copy of it. Okay. Any other questions? Okay. If you didn't have any questions إن شاء الله بنشوفكم يوم الثلاثاء where we begin chapter 2. يعطيكم الف عافيه.
يعطيك العافيه دكتور.
باي باي.